This video will show you how to multiply rational numbers. So we're still in chapter 3 and we're talking about how to deal with rational numbers. Of course, when I did adding and subtracting, I also looked at integers first, so let's do the same thing with multiplying. Remember how to multiply integers? 3 times 2, 6. 3 times negative 2, yeah, that was negative 6. Negative 4 times positive 3, I hope you said negative 12. Negative 4 times negative 3, I hope you said positive 12. And so noticing the 4 questions above, if I asked you to multiply 2 integers with the same sign, that would be this case and this case. What happened to your answer? It became positive. Where if I have you multiply things with different signs, look what happened there. Our answer was negative. Well, guess what? It's the same with multiplying rational numbers. Okay, so let's look at example number 1. I'm going to ask you to first predict what the sign of each product will be, and then we'll actually calculate it. Notice one of them's negative, one of them's positive. This one must be negative. Both the signs in part B are negative, so if the signs are the same, the answer must be positive. Part C, negative times a positive, they're different. Negative is right. And then this one's a negative and a positive, that's going to be also a negative. Okay, so knowing that, the question is, how do you multiply fractions? Well, when the denominators are different, we don't have to worry about that kind of stuff anymore. Okay? I hope you remember from your previous studies that for multiplying, just multiply the top numbers together, multiply the bottom numbers together. So in this case, 2 times 1, that's just 2. 5 times 7, that's 35. And because this answer is supposed to be negative, we're going to put a negative in front. That's it, we're done. Same thing for this one. 7 times 3, that's 21. 8 times 5, that's 40. The answer is positive. We don't need to put a plus sign in front. We're done. 3 times 10, that's 30. 11 times 7, 77. This is negative. Put a negative in front. We're done. Oh, what's this with a with a mixed fraction? My advice would be to change it into an improper fraction. So we'll keep the negative 4/13. This is now 1 times 5, which is 5, plus 3, which is 8. And now I can do the multiplication. 4 times 8, 32. 13 times 5, 65. Positive or negative? We said it was negative. So boom, we're done. Looking good so far. So just a quick note about part D. When multiplying mixed fractions, you do need to change them into improper fractions first, and then multiply the fractions. And by the way, if you do need to, you should change your answer back into a mixed fraction. We did need to for this one because the numerator was less than the denominator. But in previous examples and videos, when we did the adding and subtracting, we did have to change them back into mixed fractions. Alright, here's our next example, number 2. 3/10 times negative 5/12. So I'm going to say the answer is negative, and 3 times 5 is 15. 10 times 12 is 120. Leave your answer like this, and I won't be so happy, because I think we can actually simplify. We should be able to reduce. I see that both numbers are divisible by 5. So we should be able to divide both by 5. So 15 divided by 5 is 3. 120 divided by 5. I know we can divide by 5 because it ends in a 0, right? 120 divided by 5, that is 24. And that's pretty good, but I think we can go further. Divide both by 3, so negative 1, and 24 divided by 3 is 8. I believe this is our answer in lowest terms. Okay? Now I did ask you, is there more than one way to answer this question? And I hope you are going to say, I think so. And I hope you learn this other way too, because I think dealing with smaller numbers is always a better thing. So let me just do a squiggly line here, and let's do this again. Okay? 3/10 times negative 5/12. This is the method called cross-reducing. It's always nice to be able to deal with numbers that are smaller first before you multiply, because when you multiply, things get big. And really what I said to you earlier was we just multiply the top numbers together. So really we're just doing 3 times negative 5, and we're dividing that by 10 times 12. Now, where's this cross-reducing thing come into play? Well, really I can order things differently with multiplication. In this case, 3 times negative 5 is the same thing as negative 5 times 3. So really I could reorder the fractions and look like this. The 3 and the 12 go together, and the negative 5 and the 10 go together. Right? Well, if I had 3 and the 12, can you reduce that right away for me? 3 and the 12, I believe both are divisible by 3. So if I go 3 divided by 3, that becomes a 1. So I'm going to cross out the 3 and make it a 1. And I can do the same thing with the 12. 12 divided by 3, I'm going to cross that out and make it a, well, what's 12 divided by 3? A 4. Similarly with the negative 5 and 10, I think both are divisible by 5. So I can cross this out and make it negative 1. And cross this out, 10 divided by 5 gives you 2. And now look what I have. I have the following, 1 times negative 1 over 2 times 4. Well, that's so much nicer, because negative 1 times 1 is just negative 1, and 2 times 4 is 8. Boom! I get my answer right away. So here's my advice to you. When multiplying fractions, always see if you can cross-reduce first, so that you can do the calculations with small numbers. Okay? Alright, let's turn the page. So here are some exercises for you. Exercises mean I want you to do it. So go ahead and see if you can try these, and I'd like you to actually use the idea of cross-reducing too, because look, I see these numbers 45, 32, they're big, they're huge, and I'd rather you deal with smaller numbers. Okay, go for it yourself. I know this answer is going to be negative, right? Because one's negative, one's positive. Crossing, reducing. So 4 and the 32. I think both are divisible by 4. So 4 divided by 4 is 1. 32 divided by 4 is 8. Okay. Looking at the 15 and 45, I think both of those are actually divisible by 15. So 15 divided by 15 is 1. 45 divided by 15. I know this, by the way, because 15 minutes, 30 minutes, 45 minutes, this is like 3. So I think our answer is just 3/8. Negative 3/8. Done. Part B is a little bit trickier because you have mixed fractions, but what do we need to do first? Yes, change them into improper fractions. 2 times 8 is 16 plus 5 is 21. 21 over 8. Put a bracket around there. 14 plus 3 is 17. Okay, that's a good start. And now I'm going to ask you to see if you can cross-reduce 21 and the 14 perhaps. What number divides by both of those? How about 7? 21 divided by 7 is 3. 14 divided by 7 is 2. How about the 8 and the 17? Can we do anything there? Don't think so, so we can't just leave it as is. So now let's go ahead and multiply them together. Negative, negative is a positive, so 3 times 17 is just positive 51. 8 times 2 is 16. There's your answer, but once again, please change this back into a mixed fraction since the numerator is larger than the denominator. 16 goes into 51 how many times? Not once, not twice, probably 3 times. Has a remainder of 3 as well, so this just becomes 3 and 3/16. Okay? I hope you got these exercises right. I hope you weren't just waiting for me to do it, because you need to try these yourself, and I think you can. Alright, fractions are rational numbers, but so are decimals. In this case, I'd like you to predict which product is greater than 0. That's just another way of saying positive. And then multiply to determine the amount. Okay, and when I ask you to multiply, just use your calculator. That's all you need to do. Okay? Which ones are greater than 0? A? Don't think so, because the signs are different. B? Don't think so, the signs are different. C? Do think so, because the signs are the same. So C is positive or greater than 0. And how about D? Yeah, D I think is also. So C and D are the ones that are greater than 0. And now just to go and calculate, just use your calculator and punch it out. 2.5 times negative 3.1, negative 7.75. Go ahead and do these on your own and double check your answer with mine. Okay. So, one last question for today. I love investing. Yeah, if I had the money, I'd invest more. But I like forward-thinking technology companies as well. So I actually own 50 shares of Apple stock. And let's say the price of one share in Apple decreased by $1.25 on Monday. Then it increased by 75 cents on Tuesday. Then it decreased again on Wednesday by 50. Then stayed the same on Thursday. And then finally increased by $3.75 on, I think this should say Friday. Oops. But how much did his shares change in value during the week? So, the question is, look, when I buy a share, it's like a portion of the company. I got 50 of these. And on Monday, it decreased by $1.25. So on Monday, when I decreased by $1.25, that's like a negative. So negative 1.25. If I lost $1.25 on one share, how much would I have lost for 50 shares? I just multiply it by 50. And I would have lost, I think, $62.50. Brutal. But wait, on Tuesday, it bounced back. Not as much as I want it to be, but still not bad. 75 cents. So what's 75 cents times 50? This is a positive answer this time, right? And I'm going to just use my calculator. 37.5, or $37.50. So I got some of it back, but not enough. How about Wednesday? Oh, it decreased again. Dope! Lost money. 50 cents per share. That's half of the cost. Yikes, I lost 25 bucks. Thursday stayed the same, so really it's 0 times 50, no change. But on Friday, thank goodness for Friday, TGIF, it's an extra $3.75 per share. Woohoo! So $3.75 times 50. Wow, I made $187.50 on Friday. But the question said, how much did the shares change in value during the week? So here are my individual changes for each day in the week. How much did it change in value during the week? I'm going to ask you just to add up all these together. Add up together. And that will tell you how much it changed during the week. So, negative 62.50, adding 37.50, take away 25, adding 0, adding 187.50. Woo! In the end, I actually made $137.50. So, my shares changed by increasing in value by, how much was it again? $137.50. Not bad. See? We've combined now adding and multiplying integers, or not integers, rational numbers together. Cool, cool. See you back soon.